Hey, it's Derpy here. I thought I'd share some code that I've been writing. Um, a while ago, I went and was studying min-max algorithms and um, like depth tree um, evaluation functions with numerical values. And I followed this tutorial, and I included all of this stuff because this is on my GitHub. So I did want to include the fact that I followed their tutorial um, to write this because it was, I was reading their article and doing it, line by line, essentially, and reading alongside why they had done it the way they'd done it. I wish I commit to commenting like this all the time, but I don't. So, well, because they provided me good comments to give, so why not put them if I'm following a tutorial? Anyway, so this was the algorithm that was used to initially do all of this. But I did, when I first wrote this game state, um, excuse me, that's bad. When I first wrote this game state, uh, it wasn't for that algorithm. It was for a bad one, just a really bad one, and I've that could not beat uh, this algorithm. Mind you, no human that humans can't. I mean, humans and computers can only tie each other at best infinitely. Um, but when it comes to when it comes to the CPU that I wrote myself the first time before reading about this and writing this one alongside that tutorial, uh, it lost 50% of all the games that it didn't tie. Um, so that's fun, right? That's that's pretty bad. Uh, and I'm pretty sure it wasn't actually tying intentionally. So I decided, because I've been trying to distract myself from finals, to revisit it. I'm still gonna call it, you know, is a bad CPU, so that's what it's called. Uh, but here is the new version. Okay. Now, something that I am proud of myself for. The first version I wrote, I didn't know how to 2D array because I hadn't even taken a Python class yet. And we're not just like even a Python, not even like a like programming computer science fundamentals class at that point. Um, so I wrote it like you would with just a list, just a Python just list. I mean, I know that's what the other one is using as well, but whatever. I don't care. Um, I have this game state was updated to be used with this, which uses a 2D list, right? So, or a list of lists, excuse me, if you're getting angry that I'm calling it a 2D array or a 2D list. It's a list of lists, okay? Um, when I wrote this game state, right, it changed to use an array like this, right? Which is not just a normal, is not this, which is what this one was built for. So how do I get around that? How do I take every game state that the computer needs to evaluate the move for and turn it in to a one-dimensional array so I don't have to evaluate it differently than I already had? How do I do that? Do this. Flatten the list. Flatten the list, ladies and gentlemen. We just sum the board into a list. And since it's a board of strings, It just concatenates. Well, not yeah. Why did I say that? Jesus, not. It is a it is a list of lists. It just concatenates all of the lists into one list without changing any values, right? So that was a quick hack, which is cool. Um, so yeah, again, like I have with the other one, um, compensating for letter stuff. If you want to use this one's evaluation, you shouldn't use this one's evaluation. It uses random. You still can't beat it, but I don't use it. Uh, so just like with the other one, we're going over uh, we're going over the length. We're iterating over the length of the board, and um, returning whether or not in this one I decided that we're going to see first if we win with the move that we make anywhere. If we can make a move that wins anywhere on the board, make that move. Okay? If we can't do that, try to block your opponent from winning if they are about to immediately win. Right? And if that is not the case, then we go to our opening playbook, right? Moves that would be evaluated as 0 on this algorithm, right? These moves would normally be evaluated as 0 unless you're about to win. So, and these moves, if you play them and it's not for a tie, you're going to lose, right? So we get the move, we choose a move from the list, which choosing a move from the list, right? So what I did here to compensate for, I know what the best move, if you are not player 1, should be, right? And that is to play in the center, right? So if your opponent's letter is on the board and your letter is not, and the middle space is free, take the middle space. If not, return a move from the move list. And in this case, I don't have to filter the move list to see if it's free because that means that I'm going first, right? That means that I'm the one that's making a move first. So I can just choose any of the corners I feel like for free, and it will be the same evaluation no matter what, especially even in this algorithm, right? So we go, we get that move, we check if that space is free, we make that move, right? And the +1 is because this is a ordinal number. This is ordinal list, but we are taking cardinal number line numbers to represent the squares in the game, right? Even to the game state function. So that's why they return with +1s. Move two is just to fill in the squares that you should not play. That you should not play unless they're the only squares to be played. Because the only reason you should play these squares is if they are directly blocking your opponent from winning the next turn. Right? So, I used to just try the center if everything else fails, but then I realized the center is strategically important if you want to play intelligently. Intelligently. So there's that. Yeah. So give me 1 second and we can make the AIs play each other. All right. So there we go. Yeah, I was just making sure that was set. You'll see at the bottom here that we have uh, we have all of this stuff going on. Sorry. Uh, be a bit more articulate. So if we look at how one of these games starts, right? The player in this case is the bad CPU. Bad CPU. Um, eh, well, give me a second. Let me just pause it. Sorry, forgot it was still going. Um, so in this one, the computer is going first, right? So computer goes first. Of course, we're going to take the center because I just explained that. So the bad CPU knows to take the center. So the good CPU evaluates, well, this is a good, this is the best move for me to make that doesn't put me in a losing position. You could have done it this direction or that direction, right? And that is a winning, tying move, right? And the next move, I have to cut him off because if he if they make another move, right, then they win. So that clause is satisfied, so we return that move. So the better algorithm, uh, goes and evaluates that this is another winning move. If I'm not, this wasn't a computer as well. So I have to block that move. And of course, that's one of my rules. So I block that move. So it's the computer's turn again. And at this point, the computer has to block me, not me, the other computer, from winning. So it has to play this move, which then leads to me playing a valid move, just any valid move that's left. And one of my rules was play corners that are left if they are, that were part of the move list, right? So it plays the corner that's left, right? And then the other algorithm plays the only other move that's left. So this time, the first computer goes first. The good algorithm. I mean, the bad algorithm, excuse me. It takes one of the corners, opposite corner of what the good computer took. So, good computer also takes the center. Bad computer takes the corner. Good computer takes that because it has to block it. So bad computer then blocks it from winning. So then good computer, I think good computer is attempting to make it impossible for you to win on any horizontal or parallel. Yep. And it's a tie. Oh, it's a tie again. So, closing out here, what utility does this have? Well, next I want to train a neural network to be able to also have a model, even though I know that's really easy, that is capable of it. I want to have all different kinds of CPUs. I want to study how this stuff works and how you can achieve it and what's necessary and what's sufficient. So I just thought I'd let people know what was up. If you enjoyed the video, if you want to learn code, do it. Ask me stuff. I know some, not a lot. I know a bit. I'm not perfect, but yeah, let me know what's up.